In this lesson we are going to add like terms when we have variables under the radical. So when I first look at this problem, it's 9 root 12x plus 13 root 27x. I have to first break down both numbers and variable under my radical. So I'd have 9 times the square root of 12 times the square root of x. I'm going to do that before I even try to add it all. So over here I'd have 13 times the square root of 27 times the square root of x. So my 9 I leave alone. I'm going to bring that down. 12 is root 4 and root 3, so I can rewrite that as 2 root 3. And then when I look at my root x, can I take 1 divided by 2? I can't. And anytime your exponent is less than your index, it cannot be broken down. So I'm actually going to leave this the square root of x. So when I multiply these three terms together, I would take the 9 times the 2 and get 18, root, because both of the numbers are under the radical, 3 times x. And that's how I simplify that term. So the same idea comes over here. I'd leave the 13 alone. When I break down the square root of 27, I'd use 9 and 3. So I'd have 3 root 3. And then same idea, square root of x is not going to break down. So when I multiply these together, I would get 39 root 3x. So now I look and say, do I have like terms? Like terms means that this is the exact same. What's under my square root and my variables and numbers are the exact same. These outside numbers can be different. That's what I'm actually going to add. So when I add 18 plus 39, I would get 57. And then I leave the label the same. So it's 57 root 3x. So I want you guys to try number 9 and see if you can do it. Pause the video and then we'll go through it together. So in 9, I'd bring down my negative 2, and I'd have root 45 and root y. Then I have my plus sign, and I'd have 4 times root 20 times root y. As I break down 45, I'd use 9 and 5. So I'd have negative 2 times 3 root 5. And root y doesn't break down again because the exponent is smaller than the index. So when I multiply my outside numbers, I get negative 6. And then when I multiply into the square root, I get root 5y. So same thing on the other side. I'm going to break down the square root of 20 and then use 4 and 5. So I'd get 2 root 5. And the square root of y does not break down anymore. So I have 8 root 5y. When I look at these, I do see that I have like terms in that I have root 5y for both of these. So I add the numbers. Negative 6 plus 8 is 2. And then root 5y. Hopefully that one made sense to you. We're going to do one more together. Number 10. This one, when I rewrite it, I'd say it's 3 times x to the 5th times the square root of 48. And then you'll see it's a minus sign. And then it'd be 2 times the square root of 27 times x to the 8th. So as I break this down, I have the square root of 48 I would write as root 16 root 3. So I have 3 times x to the 5th times 4 root 3. When I multiply now, I can multiply my numbers on the outside, so 12. That x to the 5th stays on the outside, and I have root 3. Then I bring my minus sign down, and I'll break down my other term. Square root of 27 is root 9 root 3. So I'd have 3 root 3. And then square root of x to the 8th, I can take 8 divided by 2 and get a 4. So it's x to the 4th. So when I combine like terms here, when I multiply, I get 2 times 3 is 6. And then that x to the 4th is not under the radical, so I'll bring it outside. And then root 3. Now when I look at this problem, I do see that I have the same root 3's, so that might make me think that they're like terms. But my variables have to be like terms also. They are not. X to the 5th is not the same as x to the 4th, so I actually can't subtract here. My answer is 12x to the 5th root 3 minus 6x to the 4th root 3. These are not like terms. So I wanted to show you this one so you realize it's not just the square roots that have to be the same, it's also the variables. Numbers are the only thing that could be different.